everyone, welcome back to the session. In this session I'll take up power electronics questions. So before heading to the session, we recently launched a course for GATE 2022, okay, and the course launch offer is also going on. 50% offer is there. You can just visit the website lectures.py2.in. You can check the link also in the description. So you can use a coupon code in the website. Everything will be given. Just go through it, you will get it. Okay. Yeah. Let me just brief you about the website and how you can purchase the course. Okay. Let's just have a look at that. Once you go to the link, what is scrolling? If you go to the link, what is scrolling there? Here link is scrolling, right? lectures.py2.in, and these are web page how it will look like. Okay, and you can get a free demo also. You just select the course you want. Whatever the course you want, you just select the course. Right now for combo courses, 2022 course has launched, combo course. So on that you have 50% off. Okay, and once you go to the web, once you go to that page where you have, what has happened to this? Yeah, so you can select the validity. You just select the validity, how many days validity you want, any course, and you can get a free trial also. Free trial is there. You can get a free trial for 365 days. Obviously full content, limited content will be there in the free trial. Just simply like any other website, any other e-commerce site, select it. There is a price for 30 days. Okay, for the machines course, add to cart, and then that's it. Like a regular e-commerce site, a view card or checkout, you can click on the checkout button. This is a checkout. Yes, here. Click checkout and fill the details. That's it. If you have any coupon, you apply the coupon here, you'll get the things. Okay, and once you're done, once you're completed with the payment and all, then immediately you will get an email. With the course download links, because you don't have to worry about the slow internet speed and all. You can download and watch. Okay, and instantly it will be delivered to your email. That's it. You're good to go with the watching, enjoying the courses. There are different courses available. You can just go through the website. Okay, if you need any guidelines, how to buy, just click that, check it. There are simple 5 steps like any other e-commerce site. I think all of you are good with purchase, e-commerce, Flipkart, Amazon, all these things. You must be buying a lot of things. Just like that, you need to create an account, select the package, add to cart, check out. If you have any coupon code, apply the coupon code, complete the payment. Immediately you will get an email, videos as well as PDF. Means the links, everything you will get. Okay. I hope you got the process. Yes, absolutely. See, that's what the advantage is. Suppose you had taken 30 days course and you want to extend the validity. Yes, you can extend the validity. Okay, just go through the site. See here, video courses. You can extend the which course you want to extend the course validity. Okay, and of course you need to extend the validity before the course expires. Once the course is expired, you can't extend the validity. So which of the most important topics in digital electronics I have not done it till now? Ashruth, basically first 2 modules of digital electronics are of course fundamental, they're important. So next modules from Karnaugh maps, K maps, and combinational circuit, sequential circuit, they are most important things. But yeah, don't go for what is important. It's after all you're preparing for any competitive exam, so you should not leave anything like for subjects like digital electronics. That's the easy subject. Okay, I don't think it's going to take, if you're dedicated enough, if you sit for 20 days, you can easily get that subject completely. Yes. So it's easy subject. Okay. Yeah. Any other things if you want to ask? Yes. Thank you, Hariharan. Yeah. So now, having said this, let's get back to our powerlifting session, today's session. Once again, here we have the courses, the course 2022 GATE course. GATE course means it's not necessarily only for GATE. Any competitive exam, you can easily crack it once you have a good subject in your hand. Okay, so try to focus on understanding the subject. Once you understand the subject, that's it, you're good to go. Okay, so nothing to worry about. Sir, I want to prepare this exam, that exam. All exams, one solution, subject. You need to bag the subject, you need to get the subject in your hands. Once you get the subject in your hands, that's it. any exam can crack it after all, right? Because syllabus is not going to change. The depth of the questions may vary. So you should not be like, I'll prepare for upper level, not a deeper level. No, when you're taking up a subject, if you have enough amount of time, then prepare completely. Try to grab the subject in completely, try to grab the subject. Okay. Anyways, so yeah, let's begin the session. Let's begin the session. Are you all ready? Have you shared the video? Did you hit the like button? They come up with some previous year questions of TRANSCO and DISCOM exam. Okay. Give it a thumbs up quickly. Give it a thumbs up and share it. Take some time. I'll wait for a minute. Quickly share it on your WhatsApp group, Facebook, Insta. Just quickly share it. You have a link pinned on top, right? Yeah. So like every time, I'll give some free test series packages for the people who are performing better in this live session. During this live session, I'll be showing up some questions. If you're responding good, if you're engaged till the end, and if you're answering to the questions very nicely, then I will give you a free test series for you. Okay, that's the first thing what you're going to get out of this video, apart from a regular content also. And the second thing, if the video during the live session, if the video reaches to 100 likes, during the live session, then you're going to get the video courses also. You will be getting a video course at a best price. Okay, I'll give an exclusive coupon for you all, not all, for some people. Then you can get the video courses also. So share it, get the likes, reach to 100. Okay, so today is Wednesday. Let's begin with power-electronics. I'm moving to the first question. Here is a question. Oops, where is the timer? We lost the timer. Okay, let me get the timer. Yeah, what is the answer? You don't wait for the timer. Timer, I'll bring it up. Yeah, timer is calm. Let me give 20 more seconds to this. 20 more seconds I'm giving. What? Did you read the question, guys? Did you read the question? It's a single phase full bridge inverter. It's a single phase full bridge inverter. It is not a single phase full converter. Even though if it is a single phase full converter, this will be cos alpha. If you want to change the option, what you are given, you can change. I am giving a choice for you to change now. Change it. Those who are giving 2 as answer, if you want to change it, you can change it. Yes. What is the output of the single phase full bridge inverter? What is the output shape of single phase full bridge inverter? Right, type. What is the output shape of single phase full bridge inverter? What is shape? This is also called as, full bridge is also called as H bridge. This is also called as H bridge. Yes, exactly, Ashruth. Square wave. Square wave is output. Now it is asked for the fundamental component. So normally you will have, and it is asked for fundamental component. Yes. Normally it lost a RMS value, or for any n component or nth harmonic, if it is asked, it will be n here. It's a Fourier series expansion, not a stepped sign, it's a square wave. So fundamental n is equal to 1. So this is a fundamental sine component. Okay, fundamental will be this. And out of, in this is a maximum value. Maximum value of the fundamental component is this. If you want an RMS value for this, simply take this 4 Vs by pi into 1 by root 2 will be the RMS value. Okay, so it will give you 2 root 2 Vs, that's what VDC sometimes they will give, by pi. This is what the RMS value if it have asked like that. Okay, anyways, for this the answer is this, Pakka. Yes, you're right, Srivastava, Pakka 4. Yeah. Let's move to the next question. Give it a thumbs up. Thumbs up. Share it, thumbs up. Then I'll move to the next question. Rahul, Manasvi, Ek, Anusha, Kiran, Vishwa, Lucky. Good to see you all back. I think Lucky is a new one. Kiran is also new. Ek is also new. Okay. Ek. Let's go to the next one. Yes. Give it a thumb. Once question is over, thumbs up. Yes, good. Second question. I'm giving again 60 seconds. Take the 60 seconds time and answer it. Yes, Nandi. And Newton is also here with us. Are you Sir Isaac Newton? Yeah. "30 seconds left." Wow, smart, quick. Anusha, first of all, try to be accurate, then you can be quick. If you want to change the option, you can consider changing it. Encyclopedia is saying 2, Rahul is saying 1, Ashruth is 2, Revant. 10 seconds more. 4, A and B. Okay, time's up. It's my turn now. It's my turn. Okay, see the statements. So you can consider this one as, suppose if these options are not given, you can consider them as MSQ questions, multiple select questions. Okay, nowadays in the online exams they are giving these MSQ multiple select questions. So let's see as if it is a multiple select question. You need to select what are the correct options. Okay, and you need to select all correct and only correct answers. Then only you will get marks, otherwise you will not get marks. Okay, and no negative marking for these MSQs. You need to select all correct and only correct. Okay, otherwise if you mark all the available options, if you mark it, then you will not get, right? Anyways, coming back, which one is correct? IGBT has a low input impedance compared to P MOSFET. IGBT is having low input impedance compared to P MOSFET. No, it is having high input impedance, right? It won't have low input impedance. It is also taking less current. Okay. So next, let's go to the next statement. IGBT and P both are voltage controlled. Absolutely right. If it is a P BJT, power BJT, then that's a current controlled. Both IGBT and the MOSFET are voltage controlled. And I told you, I have made a video also on our YouTube channel how the IGBT and who is inventor of IGBT? The Indian person. Indian scientist. So IGBT, how we got IGBT from MOSFET and BJT, the structure and all, I think that's also right. Okay. Rahul Kale is saying first statement is correct. Okay, let's come to the first statement also once again. Anyways, let's come to this third one. IGBT can be designed for higher voltages compared to, yes, it is true. The capacity of IGBT is in between BJT as well as MOSFET. BJT is normally higher power levels. BJT is normally higher power levels or higher voltage levels, high current levels. MOSFET cannot take that much power capability. IGBT is in between those two. IGBT is in between those two. So yes, IGBT is compared to this, it is high, right? IGBT converters are made costly and bigger in size compared to BJT converter. No, this is wrong. This is wrong. IGBT converters are not bigger in size and they're having less losses, that's why we're using for high frequencies. Okay, and these are having a heat sink. The heat sink, what is having, as losses are less, heat sink size also will be less. Okay, so this is wrong. Now coming to Rahul. Rahul is saying yes, MOSFET is the highest operating frequency is MOSFET. Okay, and yeah, coming to Rahul's statement, IGBT has low input impedance compared to PMOSFET. As far as my point concerned, IGBT has, yes, definitely it has high input impedance. But now let's compare. It's coming to the comparison, right? MOSFET comparison. When it comes to the MOSFET comparison, let's see. Yes, MOSFET will have very high. This is high compared to this. Yes, you're right, Rahul. You're right. MOSFET will be having, comparatively if you see, of course there is, this also, IGBT is also having high input impedance, that is true. But now coming, now the aspect is comparison. So as aspect comparison is coming into picture, and definitely yes, we should consider, if this would have been MSQ question, forget about this, if these options are not there, MSQ, then you can, not a problem, that will be correct statement also. Even though small amount of difference is there, this is having a little less compared to this, still it is a less, right? Low input impedance. Okay, but careful, it won't be too much. Okay, anyways, so right now I need to choose one option here among these. So I would prefer choosing this, or you guys are preferring D. The option which is having D will simply ignore it. So as this ambiguity is here, they should give mark for these two, I think. Okay. Anyways, let's get into the second question. These are all PYQ questions, previous year questions of DISCOM. Okay. Next question. Timer is running. Simple question. Check it. Check it. Check it. Sorry, Aditya, I'm not a native Hindi speaker, so I cannot speak that good in Hindi. Of course, you will understand better in Hindi, but I can't speak Hindi that fluently because I'm not a native Hindi speaker. Okay. Yeah. Anyways, you have 25 seconds more to answer this question. Direct formula based question. Formula based question. Good. Everyone answered correctly almost. Others, what others are doing? Give it a thumbs up. Those who are live, give it a thumbs up. Share it. Share it with our friends. Okay, good. Time's up anyways. Let's see. Figure shows the thyristor controlling power in a load resistance RL. This is a load resistance RL. Alright, okay. The supply voltage is 240 volts. This is 240 volts. Okay. and the limit for di by dt for SCR is, this SCR is having di by dt rating is 50 ampere per microsecond. Okay. Now to have that, what should be the value of L inductor? This is snubber circuit. This is snubber circuit. Okay. Now this is to protect, tell me, snubber circuit is to protect what? Protect the SCR for under what circumstances? And what about this? L is to protect what? Yes, this will protect, this will give the protection against high voltages. Rather, not high voltages. If I say high voltage, that would be wrong statement. High rate of change of voltage. And this will protect this inductor, SCR from high di by dt. Okay, inductor. So we know the rating is given, rating of the SCR is given as 50 ampere per microsecond. So what should be the value of inductor such that the current through this will never exceed this rate of change of current for this given 240 volts. So the formula is, you know the formula for inductor voltage, VL is equal to, any inductor, just general I am saying, VL is equal to L di by dt. So the same formula we'll use here. VL is equal to L di by dt, we'll use the same formula. Now voltage across inductor is, the moment is closed, 240 will come here, 240 will come here. Okay. Now you may ask, sir, we have a resistance here, there will be a drop. No, there won't be any drop because inductor will not allow sudden changing currents, it will act as an open circuit. The drop across this is 0, the entire 240 volts will appear across this. So this is 240, this is 240. Now L value is not known, di by dt, we should restrict this di by dt to 50 ampere, don't take just 50, it is 50 ampere per microsecond. So L is equal to VL, that is 240 divided by 50 ampere per microsecond. Okay, so it will be 240 by 50 microhenry is the L value. So it is asked in terms of microhenry, so 240 by 50, if you do that, you should get this. Okay, yeah. Let's get into the next question. I think you can see the new course launch, as I was saying, new course launch for GATE 2022 users. What are the availables? Check the link in the description. Course has launched, you will get it at 50% off and it is valid till the 2020 GATE 2022. Okay, you can get this, you can grab this opportunity, those who are willing. And the lectures, I think you must have watched our lectures. Okay, they are not just you're having a lecture, just a lecture is there, it's done, boring lecture, and you must be fed up with this online class and all. But these lectures will be something different. It will be really engaging and you will be enjoying when you're learning. Okay, just give it a try, take a free trial. I told you how to get a free trial. Just go to the website, get a free trial, try and have a look and enjoy. Okay, yes, moving to the next question. Yes, I think this requires maybe, let me give 80 seconds. Those who are having little friction in answering this, maybe they'll take little time, but yeah, it's actually 60 seconds question. Give it a thumbs up, thumbs up. Once the question is completed, you need to hit the thumbs up. Like, your like is energy for me, not just for me, for my team also. Okay, give me some energy, synergy, energy. Wow, synergy means I'm recalling something when I heard the word synergy. Okay. Good response. Yes, Rahul, you're right. It's a step down chopper. You're right. That's the first thing. Rahul, you've done well. The first thing what you should identify is immediately when there is a question based on a chopper, You should identify the type of chopper immediately. That's the first thing. Any question, whatever the question is given, you should identify type of chopper. This is a step down chopper, basic step down chopper, okay. Now once you recall it's a basic step down chopper, immediately you should write V0 average is equal to del into V input Vs supply voltage. This is what the V0 average. This is what you should write immediately. You should write on a paper. Okay. Then look at the question. Till then, don't look at the question. Don't even read the question also. Okay. Now we have written this. Now read the question. For the simple chopper circuit, the average and RMS currents for the duty cycle of 0.49 in amperes are. Neglect the voltage drop and all. So you need to find the average current. So to find out the average current, you need to find out the average voltage and RMS voltage. Okay, output average voltage and output RMS voltage, you find it. That's it. So output average value is how much? 0.49 is a delta into 200. That is what the V0 average. Okay. Now I want current. So divided by this resistance 10. Now you may ask, sir, we have inductors also. The average voltage across an inductor is 0. The average voltage across an inductor is 0. The entire average across this only. That's why I'm not including this, because anyways the average value is 0 here. Okay. So once you solve it, 0.49 into 200, you will get 9.8 as average current. Average current is 9.8. So the first one is having 9.8. These are only option we are having 9.8. You can mark it flawlessly. Okay. You don't have to even go for RMS current, because this is the only option available. Now anyways, what if RMS current you have to find? Suppose just for the practice, RMS formula square root of del into Vs. Okay. Now if you want I0 RMS, then simply V0 RMS by R value. Okay. Just calculate this. You should get here 140. R value is 10. This is 14. Is answer. Okay. Give it a thumbs up. BDC del RMS is equal to BDC into root del. Okay. Anyways, this is clear, I think. Give it a thumbs up. Shall I move to the next question? Yeah. Okay. Next. This I'm giving 60 seconds. Oh yeah, I got it. VDC into del, yeah, RMS value is VDC into root del. Yes, Anusha, you're right. Yeah, I understood now. Okay. I think my mind is not functioning properly maybe. I couldn't figure it out. I should have figured it out. But yeah, maybe I'm looking at different aspects, so that's why my mind is blank when I look at that statement, I think. Anyways, okay. Wow, Aditya Sharma has answered. Yeah. Now what is the answer for this question? Good, not bad. Let's see how do you solve. A separately excited DC motor is energized from 440 volts 50 Hertz 3-phase full converter. It's a 3-phase full converter. So 3-phase full converter means AC to DC converter. That's average value is how much? What's the formula for average value? 3 Vm by pi into cos alpha. 3 Vm by pi into cos alpha is a V0 average formula. Okay. Now what is the Vmax value? Vmax value is 3 times of 440 into root 2, 440 into root 2, 440 into root 2 by pi into cos 45 degrees. Let me just calculate it. Root 2 by shift into cos 45. You'll get, oh no, what's that? Did I do something wrong here? No, I done correctly. No option. Oh, 420 available. I didn't see that. This is answer. This is answer. This is the answer. How you guys have got 3 and this? You are getting different answers. 420 is answer. Okay. Simple formula if you know. And here Vm means maximum value. These are RMS value. You have to take the maximum value. That's it. Okay. So what's the mistake you had done? What's the mistake you had done? Yes, Anand, you're right. You're absolutely right. Okay. Shall I move to the next question? Give it a thumbs up. Give it a thumbs up. Give it a thumbs up. I'll move to the next one. Give me some energy. I'm waiting for your energy. Yeah, I got 1. If I'll get more, it'll be more happy this thing, but okay, I'll move with at least 1. This is a theoretical question. I think you should answer this in maybe 40 seconds. Yes, thanks for the energy. That's a good energy. Saga, Glajit, Aditya, Srivastha, Anand. Yes, dear. Yes. Okay, quick. Move to the next question. That's good. That's good. At least at the end of the question, if I have these kind of responses, I'll be charged enough to get into the next question, little energetic way. Yeah. Yeah, time's up anyways. All of us saying 2 is answer. 2 is answer. But actually wrong. This is wrong. Which one is correct? Step up cycloconverter. Careful here. Step up. Not a dance. There is a movie related to dance. Step up, right? Not that. Step up means increasing the frequency. Cycloconverter with output frequency is more than input frequency. Means less time period. Less time period. If input is something like this, output is having less time period, means something like this. It will have something like this. For this kind of operation to happen, you need a forced commutation, because here forcefully it should be commutated. We need a forced commutation, so this is right. For a step down means increasing of time period. It will naturally commutate it. Natural commutation is good enough. Natural commutation will be enough for this step down cycloconverters, means for the increased time period. Increased time period means output will be something like this. Output will be something like this. Here and again negative. So here at this point, naturally this thyristor will be commutated. You don't have to go for forced commutation. Line commutation or natural commutation is good enough for step down cycloconverter. Now step up or step down cycloconverters can be load commutated for any type of load. See, we know load commutation means you must have on the load side, you must be having that C and L values, and that's if you're having only resistive load, how can you go for load commutation technique? That's not possible. Anyways, A, B is correct. A, B is correct, not C. This is wrong. Yeah, this is answer. Okay. Are we good to go? Yes, Ashrat, you're right. 3 is right answer. Dear Cha, you're also right. Only 2 guys have answered correctly for this question. Is it a tricky one? No, not that tricky one. Anyways, give it a thumbs up. I'll move to the next question. Give it a thumbs up. I'll move to the next question. Share it with your friends as well. Share it with your friends as well. Next question. Yeah. Let's see how many will be answering this question. The one who answered this question correctly, I'll give you a test series for free. The one who answered this correctly, I will give the test series for free. Within time, obviously. You can check test series from exam.py2.in. exam.py2.in. You can get the test series just for ₹99. You will get the test series. Okay, online test series. You will have around more than 700 to 800 questions will be there. Okay, you can attempt those questions. You can practice those. That will help you a lot during the practice. Okay. Yeah. Time's up. The correct answer is 3. 3 is the correct answer. Okay. So Ashruth is a winner. You got Ashruth test series. Give your email ID. You will get a test series. Free test series coupon code from exam.py2.in. Okay, give your email ID. exam.py2.in. Yeah. Okay, let's now have a look at the explanation. Yes, Ashruth, I have got your email ID. Let's have a look at the solution now. Single phase voltage regulator is having input is this much and load of 10 ohm means a resistive load for 9 cycles on and 7 cycles off. The RMS output voltage and input power factor are. See here, this question, this is what? What is the type of converter? Can somebody write what is the type of converter used here? Don't say AC voltage regulator. What is the type of converter used here? Yeah. Integral cycle control. Integral cycle control is used here. What is the advantage of integral cycle control over phase control, regular phase control rectifier? And there are some advantages, there are some disadvantages also. Both are there. Okay. Anyways, so for an integral cycle control, output voltage is equal to square root of number of on cycles by number of on cycles plus number of off cycles into input voltage RMS. So input voltage RMS is 220. Square root of on is 9 cycles on and 9 plus 7 off. So square root of 9 by 16 into 220, you will get 165. You will get 165 volts. Okay, simple formula. If you know the formula, that's it. And these kind of simple things also, then what do we do? So give me a chance for free registration, please. Yes, I'm giving chance. It's not just to you, Vijay. I'm giving to all who are live. I'm giving every time I'm coming live. I'm giving a free chance. Okay, open chance to all. Anyways, now what about? See, let's have a look at the power factor. How do you find out the input power factor? We know. Consider lossless system. Input power is equal to output power. Okay, input power is Vrms Irms cos phi is equal to output power is V output RMS into I naught RMS. It's a resistance, so cos phi is 1, unity power factor. And these two are same, they're constant. So cos phi is equal to V naught R by V supply RMS. So just now I said formula for V naught RMS is, this is a formula, of course this is RMS value. This is a formula. If you divide this with V SRMS or V input RMS, both are same, right? So this will be cancelled, you will get cos phi as square root of on by on plus off. These are input power factor. So that will be root 9 by 16. Root 9 by 16. If you do root 9 by 16, you will get 3 by 4, that is 0.75. This is answer. Anyways, we marked it, but of course, yeah, we need to know how to solve this. Sir, any offer for individual courses? Right now, no dear. Oh, Rahul, nothing to worry, nothing to worry, nothing to worry. Stay calm, eat healthy, okay, eat healthy. Very soon you will recover, okay, and once you recover, just inform us, all of us. We all will be waiting for your quick recovery, Rahul. Nothing to worry. And be careful, stay isolated, okay, stay isolated. Okay, 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 no calcium in hospital, not a problem, not a problem. Next question. It's good to see your dedication towards attending the session, even from hospital. Yeah. Next question, I'm giving 60 seconds again. Quickly solve it. Yes, if we get here, oh, likes are today very less. I think you're not shared the video, maybe. You're not shared. You should share the video. You should have done by now. Then you will be getting individual course also. You will be getting, good offers. Yes, answer it. Not bad. Yeah, time's up. I have already solved this. I have already explained the formula for this full bridge inverter or H bridge. In the first question, I think fundamental component formula is what? Their formula was asked 4 VDC by pi into sine omega t. That's what a fundamental wave itself. Now it is asked for RMS value only. So forget about this and divide with root 2. That will give you 2 root 2 VDC by pi. 2 into root 2 VDC, 2 root 2 VDC is 220 by pi. You're getting, oh no, we don't have that here. So 198, I got it as 198.06. But which one is matching close to that? That's what we need to be careful. Yeah, this is close to that. So answer is this. 140 root 2 is answer. Okay, 140 root 2 is answer. So yeah, whenever having these kind of options, okay, whenever you got these kind of options, don't go just like this. Simply you have here 220, just divide 220 by pi, keep root 2 as it is, 220 into 2 by pi, you get 140 point something. Okay, I left this root 2 because in the options root 2 is there, so don't multiply with root 2. 2 into 220 by pi, you will get 140 point something. So 140 point something into root 2, that's answer. Yeah, you're right. Okay, give it a thumbs up, give it a thumbs up. Let's move to the next question quickly. Yeah, are you all ready for the next one? There are just 6 more questions. Let's wrap it up a bit. Yeah, quick. I'm giving 90 seconds time for this. I'm giving 90 seconds time for this. Go ahead. Yeah, 50 seconds more. Nice, Rahul. Good. Good responses. 20 seconds more. 20 seconds more. Sit down with your calculators. Try doing it. Pen and paper. Use pen and paper. We're not Baba to get something from the middle of the air. You can't do that. So you need to write it on a paper. Bam. Time's up. Okay. Let's see. Let's have a look. The speed of separately excited DC motor is controlled by three-phase semi-converter whenever it's power electronics linked with the machines. So it will be easy one. If you know the basics of machines and basics of fundamentals, things will be easy one. Immediately write the formula for this. Can somebody tell me what is the formula for this? Three-phase semi-converter. Of course, you can't type, I think. Let me write that. Three-phase semi-converter formula V0 average is equal to 3 VML by 2 pi into 1 plus cos alpha. Okay. 3 VML by 2 pi into 1 plus cos alpha is a semi-converter average voltage equation. And I have given in the course, in the power electronics course, normally students do afraid a lot about the waveforms. They're afraid a lot about the equations. Okay, I have given a technique. I have developed a technique, a beautiful technique, which will help you to easily, very easily, you can get the things done. Okay, you can draw the waveform for any power electronics circuit, not only undergraduate level, even postgraduate level. Circuit waveforms also you can draw it if you follow those techniques. And the formula almost for all the converters formulas, all the rectifier formulas, I just given one formula. Based on that you can get any converter formula. Okay. Yeah, and as free course is there, you just go to our website, take the free course and have a feel of the power electronics. Okay, it's a free course, right? Take it. Enjoy the free course. Okay, once you have this equation and this voltage, some voltage, the input voltage is this much, so directly find out what is the output voltage. Okay, so then power electronics part will be completed. If you do this V0 average calculation, power electronic part will be completed. VML, should I use directly 440? No, 440 into root 2, 440 into root 2. If you do that and simplify it, you will get, I have the value, I am giving it 507.18 volts you will get. So now it will be just like a DC motor, separately excited DC motor, which is fed from 507.18 volt. Okay. Of course, this voltage source is fed from a three-phase semi-converter. How does it matter? Somehow I am getting here 50.18 volts. Now it is asked about, we have resistance here, 1 ohm resistance, motor torque constant, the constant value is also given, 2 Newton meter per ampere, and firing angle anyways it's taken here, and the back EMF is asked for 50 Newton meter. You need to find EB value. We know the equation, direct simple equation, EB is equal to V minus IA RA. You know the value of RA, 1 ohm. You know the value of V, this is the value. Do you know the value of IA? No, you don't have the value of IA. Your motto is to now find the value of IA. Okay, so try heading towards calculating IA. Now torque is given. We know torque is equal to Ke phi into Ia, where Ke phi is a constant. What's the value of this constant given? Directly this constant value is given as 2. This is 2. And now T is 50 Newton meter. So for 50 Newton meter, IA value will be how much? IA will be 25 ampere. So put this 25 ampere over here. 25 into 1 is 25. 25 minus this 507, you will get it as 482 point something. So these answer. Okay. Are we clear? Are we clear? Shall I proceed to the next question? Though it seems to be complicated, but it's not complicated. It's a lengthy, not even lengthy also. You need to club the concepts of here and here. Okay. You need to club the concepts here. Okay. Yes. Let's get into the question. Whenever there is a combination questions, sometimes questions used to come from networks and power electronics, sometimes it just comes from networks and machines. Then if you stay calm and think properly, you can easily answer those kind of questions. Okay. Let me head to the next question. I think this is an easy one. I'm just giving 50 seconds, though 50 seconds is more, but yeah, take 50 seconds. Yes. Give it a thumbs up. Thumbs up. There's the thunder. Yeah. Good. Very quick responses. Just we're left with 5 more questions after this. Gautam is a winner for today's session. He has got test series. Good. Everybody answer correct. Everybody have answer correct. 6 seconds left. Those who are live, try to answer. Yeah, time's up. It's a 2-quadrant drive. It's a 2-quadrant drive. To be more precise, this is which type of chopper is this? Can you say type A, B, C, D, E, right? Which type of chopper is this? Can somebody say quickly? Yeah, I'm waiting. And tell me in which quadrants this chopper will operate. Of course, it is 2-quadrant. And what are those quadrants? And what are those quadrants? What are those quadrants? Yes, what are those quadrants? I'm listening. You're not saying. What are the quadrants in which it is operating? It is operating in which quadrants? No answers. What are you guys doing? Yes. Yes. One and 3, 1 and 4, type C. No, no, no. This is type A is not. A is the first quadrant, B is the second quadrant. C, no, it's a D. Type C is both first and second quadrant. This will operate C here. Careful. Here. When you have these two closed, this voltage V0 will be positive. V0 will be positive and current flowing will be in this direction. And when these two are conducting, current will still flow in the same direction. So current I0 is always positive. When this and this conducting, V0 is positive. When this and this conducting, V0 is negative. Means first and fourth quadrant, type D. Okay? Yes, Rahul, you're right. Then how come you given an earlier type C chopper, Rahul? Next question. I think this question has come already in the previous one of the sessions, in one of the previous year paper. Same question I have explained already. Yes, you're right, encyclopedia. Yes. Yeah, anyways, what's the answer for this? Oh, timer has not begun. I'm just continuing that. I already given this question. I already explained this question. Okay, I already explained this question also. In one of our sessions, power alternate session, that's a repetitive question. It is even repeated once in gate exam also. The same question has come. Answer is load inductance is large and source inductance is small. Small. Yes. Yes, Gautam, you are the winner, obviously. Load inductance is large and source inductance is small. These answer. Okay, already explained this in one of our sessions. Okay, let's move to the next question. Wow, it's easy one. Let's see how many of you will answer. Let's see how many of you will answer this question. Easy one. Easy one. If you know the concepts, basics of the concepts, then you can easily answer this. Yeah, those who are live, give it a thumbs up, and you can visit the link in the description. And if you're new to the channel, subscribe to the channel. And those who are subscribed to the channel, ring the bell so that you will be notified. Wow, very good. Almost everybody answered correctly. Almost everyone answered correctly. Yes, this is answer. Yes, Gautam, I told you, right? You will get a free test series from exam.py2.in. We have received your email ID. We will send you a coupon so that you can get a test series for free, absolutely free. Okay. Next question. This is also, I'm giving same 50 seconds to this. I think you can answer it. Yeah. You need to think a bit, a basic question, but of course a tricky one. Yeah, there is a little small trap. There is a trap, and be careful, don't get into the trap. Everybody has fallen into the trap. I'm saying that there is a trap. There is a trap. Oh, Gautam Shina, who is a winner? Is this somebody else? Is it somebody else? Oh, Gautam is not the winner. Sorry, Ashrut is a winner. Oh, no. Anyways, let me not disappoint you, Gautam. I will give you also the pre-test series. Ashrut was a winner. He is supposed to get that. Of course, we'll send him as well. We'll send Ashrut also. I just missed that. I was announcing you as a winner. Anyways, as I announced, let me not disappoint you, Gautam. I'll send you also the coupon and give me your email ID also. Okay. Anyways, answer is, this is answer. Answer is this. 3-pulse converter has a freewheeling diode across its load. Freewheeling diode across its load. The operating range of converter is, so it's a 3-pulse converter. 3-pulse converter means it's a 3-phase half converter. Okay, 3-phase half wave rectifier. Okay, half wave control rectifier, because we're having alpha also. And here alpha ranges from 0 only, but till 150 only. Okay, because when you have 3-phase waveform something like this, alpha 0 instant is, this is the instant where alpha is 0. So 30 degrees you are leaving, and from here you are starting counting. So from alpha is equal to 0 till 180 it will conduct, means from omega t is equal to 30 degrees to omega t is equal to 180 degrees. It doesn't mean that alpha is equal to 30 and alpha is equal to 180. No, alpha is 0 only here. We will trigger alpha 0 at omega t is equal to 30. So to ask about the operating range of the converter in terms of alpha, yes, 0 to 150 is operating, and you have a freewheeling diode, so no, there won't be any conduction in the second quadrant. If number of pulses increases, then ripple is decreasing. Session. Thank you all for joining the session. Share this video with your friends, and do like the video. Do check our courses and get our free courses also, free trial courses. Okay. let me end the session. Thank you. See you in the next lecture.